Unit 3, Lesson 1, Getting Ready for a Pool Party. Before we begin, take this definition of a function and copy it into the back of your workbook. A function is a rule that assigns one output to every input. Imagine you were standing in front of a Coke machine and you made your selection, you pressed the button, and 2 drinks came out. Well, you'd be happy for that, but you could say that the machine was not functioning correctly. For a rule to be considered a function, if you put something in, you get one thing out. Now, we're going to be looking at functions in this unit, specifically with the context of getting ready for a pool party. So, in our launch area here, we have 6 steps, and they're out of order. They're probably not what happened. Now, there may be more than one order that could be correct, but we're just going to use one example of an order, and then we're going to graph it. So Sylvia is trying to empty her pool, and she's probably going to start by using a hose, this one right here. And more likely than not, what's happening is it's attached to a pump. So she pumps it out, and then you get down to a certain point because of the curves of the pool and the different depths that maybe the pump stops working. So now she's got to remove the water with a bucket. So maybe she does this next. But then she finds that there's a little too much water, and she calls some friends over, and some friends help her to remove the water from the swimming pool. Well, after having done that, she's probably pretty tired, so maybe she takes a break. And after she breaks, she cleans her pool. And finally, she gets the garden hose and she fills up the pool again. You could argue about maybe there's a different order, but let's just try this order. So we've done number 1. We've numbered the activities to indicate the order in which they occur in the story. So now we're going to use this graph to plot that out. Now, there's no numbers on this graph. It's just an overall impression or interpretation of what might have happened. So the first thing we said was she's draining water with a hose. So let's drain some water. Let's pick a spot here on the y-axis, and maybe this is the height of the water when the pool is full. And she's constantly draining it at the same rate. But she gets to a certain point, and then she starts draining it by hand. So it's flat for a little while because she's getting ready. She's going to scoop the water. And then when she scoops the water, it instantly drops to a different level. And she goes and dumps that water and then comes back, and then it instantly drops again. Now, this could go on for who knows how long. But let's just say that that takes that second part of the story into account. So first part of the story, she drained the water with a hose. That could be here. Second part of the story, she's draining it with a bucket. Now, she may come to realize that this is more work than she can do. So she calls a couple of friends, and they start helping her. Now, the difference between 2 and 3 is you're going to have those buckets going down into the water and bringing out the water a lot faster with 3 people than you are with 2. So the width of these intervals is probably going to be smaller, maybe like this. And they don't really overlap each other. It's just that when you take the water out with a bucket, the water level instantly drops. Okay, actually that would be down here. Okay, now she's going to take a little break. So when she takes a break, it just stays flat for a while. And now she's going to clean the pool. And when she cleans the pool, it's probably going to be flat for a while. And I'm going to put a point in between here just to make these two look separate. But, I mean, she's putting in a little bit of water maybe, but not enough to make much of a difference as she cleans the pool. Okay, so now she's got the pool clean. So we've gone through steps, We've gone through step 4, which is to take a break, and step 5, to clean the pool. And now finally, she's going to turn on the water, turn on the hose, and it's going to refill all the way back to where she had it before. Okay, and there's number 6. There's my story. You see the places where the graph is discrete or continuous? Yeah, when she was using the buckets, when her friends were helping her with the buckets, it was discrete. And where she had the hose on or where she had the pump on, it was continuous. Question number 2, does our graph represent a function? Well, of course it does. Why? Because at any time, time is the input, at any time, there is only one level of the water. It can't be 2 different levels at the same time. That wouldn't make sense. Would all graphs created for the situation represent a function? That means if you did it and you drew it slightly differently than me, would that have been a function as well? And you'd have to say yes, because it's still true that at any one time, the water was at a specific level. So under takeaways, a relationship is a function if and only if, well, we already wrote that down. That was the very first thing. Some key features of functions. Functions have x-intercepts at times, places where they cross the x-axis. Functions have a y-intercept. Functions have increasing areas or intervals of increase They also have intervals of decrease. And let's see what else. Functions have maximums, or a maximum, and a minimum. Now that would refer to the y value, the biggest or the smallest y value on the graph. In our case, when the pool was full, that was its maximum. When the pool was empty, that was its minimum. Okay, we have a few other terms. Domain. These are all allowed x values. Who allows them? Well, they're allowed by the story. So could the pool have gone down, let's say, or could the pool we had talked about it a million years ago. No, there were no neighborhoods a million years ago. So you would really be allowed to put negative 1 million as an x value. A range refers to all possible y values. Now, I've used allowed for domain and possible for range. Basically, you pick the domain and the function has a certain kind of range. So in this case, it would have been the height of the water in the pool. So if you called the surface level of the pool, if you called that 0, then you couldn't have any positive numbers in the y, in the range. And if the pool was, say, 10 feet deep, well, then negative 10 would be the smallest you could go on the y value. So not everything would be allowed in this story. Of the vocabulary here, we talked about just about all of them. Rate of change was present here. Rate of change was found in the story when it said that the water from the hose went out at the same rate as filling the pool. So those were slopes. That's why your slope on the left side, the angle, should be comparable to the slope or the angle on the right side. The minimums, the maximums, the maximum was the height of the pool. The minimum was how low was the pool after it was drained. Okay, we're going to skip the retrieval, and that's the end of the lesson. So that's 1, 2, and 3. We're knocking off. So in this summary, in this lesson, we created graphs to model a story context. We learned the mathematical words to describe the key features of functions. These key features are used to analyze and compare functions. So we'll see you next time, okay?